Phoenixy. Hi, I'm Andrew Armstrong and welcome to the back of this Teardown lab. I'm repairing this device and you might just see it, I'll zoom in, it's a Taito AAM60009 power supply as found in their arcade cabinets and cocktail cabinets of, 1980s vintage, I want to say. Now this has got a very weird fault where the 12 volts is collapsing when power's applied. It just lasts for a fraction of a second and goes no. And I'm not sure what the problem is. I mean, it could be any of these caps, it could be any of these regulators. There's all sorts of jazz going on. So what I've found on my shelf of curiosity is a brand new PC power supply that will easily fit in the enclosure that this fit in. And basically my intention is to bin this and put this in the same box that this was in, so it looks legit, but it's a modern switching power supply. Now I looked high and low on the internet and I couldn't get the connector spec, what the pinouts were. So I did a bit of research and buzzing out and messing around, and I've worked this out myself. So hopefully it's correct. So what I've worked out is this connector right here, and this being the bottom edge of pin 1, which is marked by that, basically provides a power on reset to the unit, a bunch of grounds here, plus 5 volts, a minus 5, a minus 12 that this cabinet doesn't use, hence I've got it white at the moment, and 2 plus 12s. So that's all the same things that our modern power supply actually provides as well. So we're good to go with that. That's an excellent start. And so what I've done is I've looked at a modern power supply pinouts, and you can see from here we have plus 5, minus 5, ground, which is the other ones we need. Where is it? Minus 12 somewhere. There's a minus 12 even. So it has everything, but it doesn't have the memory clear function, which basically that the power on reset. So what that does, when the power supply has stabled, it pulls the logic board on the device high or low. I do forget, and that tells the board to wake up. So modern PC power supplies don't have this, so I'm going to make a circuit to deal with that. Not a problem at all. But first things first, the connector on here will not plug into the arcade cabinet, and I don't want to start cutting up arcade wiring looms. We want to try to keep it compatible. So I want to make an adapter to go to here. So what I've got is a bit of an old PC motherboard, and I found the ATX connector there. So I'm going to desolder that, and our project will begin in earnest once I get this off. Whew, that did not want to come out. No sir, no siree. That was horrible. Crikey, that took a long time. Right, oh, let it cool down a moment. One moment later. So there we go, you don't need to buy nothing. It's good in the hood. So let's get all our pieces back here again. I tell you what, there's something about desoldering when you're not too bothered about saving the item that give you a little bit more freedom. Freedom! Oh, we've got the little extra connector here too, so we'll use that one. So it plugs in there like so. Ugh. Yeah. Or at least it would have if it wasn't a little bit deformed, but we'll get it in. We'll get it in. Come on! There! Now it's plugged in, it's never coming out. So, I just realised I've got to do the same thing, get that thing off. But before I do, so my plan is to take this one off, and I'm just going to wire it up direct. But technically, you can see from the bottom of the board, we had some common connections, and when my camera finishes focusing, I'll also bring this up, and you can see a block of grounds, and a block of 5 volts and a block of 12 volts. So don't say things like volts is. So there's our grounds. You see them all bundled together there. There's the plus 5s there, and there's the 2 12 volts. And then you have a minus 5 and a minus 12, and then a couple on the end. You can see them going off. They go off to the NE555 to do that weird reset thing that we're going to have to think about. So we can decide later how we're going to do this, if we want to attach a wire to each of those and double up on the connectors, or we're just going to bus across. I don't rightly know yet, but I still have to get that off. So I'm going to do a jump cut, and this will be off in the next scene. There we go. Nice to see you, nice. So what we're going to need is a bunch of wire. Wire. I have some wire. Old power supplies are great for wire. Look at that, loads of it. Absolutely loads of wire. I've got my diagram here, I'm just going to check. There are numbers on these things if you study them closely. This one is pin 1, this top left corner here. So I'm going to hold that down like that. Sorry, am I losing my mind? It says 1 there, but when I flip it over, it has a kind of a 2 written there. Interesting. Nope, that was correct. This one is pin 1 and that's pin 2. And then when you flip it over, it has a 2 where the pin 1 is. So just to blow your mind. So we won't worry about that because that's going to be hooked up to our whatever we're going to do. In fact, I can show you what I'm going to do. It's this. I've got the booby board, but this is the power on reset version. So I've done, I've reprogrammed this. It just took a few minutes to actually write the code and seconds to code it. But what it does, when this board is powered on, it actually incrementally switches 4 of the pins from high to low, 5 volts to 0, yeah, over the course of 1 or 2 seconds each. I do forget, I think it's 1 second each. It goes. At the same time, it also pulls the other ones from low to high, so you've got inverting, so you can choose whether you want inverted or regular, and then you can choose by choosing which pin you want, if you want it to be the 1 second, the 2 second, the 3 second, and 4. You can actually give this V in or 5 volts, it's up to you, whichever you want. I would probably use V in from a 12 volt source and use the onboard regulator because that'll give you a very hard 5 volts. So yeah, the booby power on reset. If you want one of these programmed up, just ping me and I'll get you one. I'll put them on the shop or something, but I'll put a firmware option for the poor version. So meanwhile, excuse that plug, but now we've got to do some work. So what I'm going to do is I'm just going to cut up a bunch of wires. I'm going to cut myself a few black wires. I'm probably going to do maybe 2 or 3, maybe 2 strands each, maybe 3 for ground, just to make sure I got plenty of wire there. And I'm just going to solder from one end to the other. So what I'm going to do is prepare the wire and prepare the heat shrink, and we'll make a few of these connections. And hopefully actually that's pretty much it before having to work out what we're going to do with this bad boy. Time to look at the specifications. We got our ATX power supply. Let's see if we can start soldering some of these wires on. We got our grounds here. Grounds, rather conveniently, are these black ones right there. So we've got 3 in a row. So just to show you what to do, get your connector, hold it steady, get your pre-tinned wire. So I've tinned the end with solder. If you haven't seen me do it before, just catch one of my earlier videos, and I've done got a bit gnarly on that one. And I'm just going to touch it on there and solder it on, making sure of course it doesn't do what that one did and sort of short out the next pin. We'll have a look, zoom in on that one, and you can see how bad a job I did. No, it's fine, it's right there, looks just dandy. So I'm going to take another one next to it there. Bang, and that's it. That's the 2 ground wires. So I'm just going to work my way through, attach these. So we've got our ground wires. We're going to use this orange colour for the plus 12 volts. And I'm looking, where's the plus 12? Oh, so I actually cut 2 plus 12s, but it looks like there's only one on these. Is that right? Is that right? Yellow. Hang on a minute. Hang on a cotton picking minute. Yellow, red. I'm looking at this extended connector. Be careful of that. Remember, there's an extra 4 on the one I'm looking at. So 12 volts is yellow, and if you look through here, that is the only yellow in the whole thing. In fact, there's kind of two 2 yellows and a purple. So I'm going to use those 2. I assume the extended ATX specification has another additional 12 volts. I'm pretty sure that's what it is. So I'm going to solder that right on here. And you can always buzz these out with a meter before you attach it to your prized antique arcade machine. I wouldn't advise just bunging it straight on anyway, that bit of pre-testing. Because something else we've got to do, of course, is convince the ATX power supply it wants to come on. So we've got blue. There is something blue here. Blue is plus 12. Oh, hang on. Dark it! Yes. I clearly wanted these as plus 5 volts, and then that one blue is the plus 12. So I'm going to erase my previous soldering. Doesn't take too much effort, and then just hook it on to the other pins. You can see how quick it is, right? Once you have everything tinned, and because this connector was a salvage one and it was effectively pre-tinned, it just all flows. Flows nice and easy. Like a yogurt. Flows like a yogurt. Let's get our 12 volts now. And something that's really cool about using one of these power supplies, of course, is that you get all of these other sort of hard drive type things and additional power lines. So if you want fans and things like that to be whirring away, you can just hook them up. You can just hook up sort of standard PC accessories inside your case, and there's always the need for the sort of additional cooling. So I think I've got that right. Purple 5, blue is the 12 volts. So then we have a minus 5 volts, which will probably connect to this purple, which it says on here on the spec is a white connector. I'm not seeing a white one just yet. Well, I'll be. It definitely has a minus 5 rating on the instructions right here on the information panel. That's right there, minus 5, 0.8 volts. I've sort of been going through its PCB here, just sort of looking at where all these wires are coming from, and you've got your 3v3s here, you've got your ground bundle, you've got your plus 5 volts here, you've got that blue wire there that's going to minus 12, very distinctly going to minus 12, and your yellow wires, which are 12 volts, and yeah, scouring, I just cannot see a minus 5 written anywhere on this board. Very strange. Dang, that's annoying. On with some heat shrinking. It's quite odd. I double checked that the unit that this thing is powering doesn't actually need the minus 5 volts, and it doesn't, so that's not a problem in this case. But if you'd gone out and bought this power supply specially and then only found out that it didn't have that wire, it's going to be pretty annoying. But you live and you learn. I got away with it, and I didn't have to work out how to derive a minus 5 volts from all of this thing. I'm sure you can do it though. You could probably get a power regulator, you could probably do some horrible things with a minus 12 and a plus 5 that shouldn't be done. But there you go, half the heat shrink is on. So all you need to do when you got this far is hold it by its neck and apply some heat. Nice. Good job on there. So that's sort of blown my mind. I need to double check what I've got here. I've got ground. I've got 5 volts. I got 12 volts going on. That's looking like most of the things I need. Let's check. Ground, 5 volts, 12 volts. We don't need our minus 12 volts, so we don't need our minus 5 volts. And that's it. I can start soldering to the other end. Fantastic. Let me get on to that. And then I'll show you how to do the little circuit this end, the little jumpy thing to stop it complaining and not booting up. So the first thing I want to show you, we have these things bust up, and if you recall I cut 2 wires for each of these, but you still have several pins to connect. Now I've got a little hack for this. If you've got appropriate wire, you can do it right off. I don't have appropriate wire, but I have fuse wire. This is 10 amp fuse wire. So all I'm going to do is take one connector, one end, apply some solder there, and just double check that is what you want. Yes, it is. These two banks here are the same banks of ground. And then just solder a bit of your fuse wire onto that one end. Nice and gentle like. Taking care, of course, to clean your soldering iron before starting this. There, that's better. And then what you can do, yeah, what you can do if you manage to solder it on there, come on now, stay boy, stay. That's better. Is wrap it, or just, you can actually just, you don't really need to wrap it in this case, to be honest with you. Just get it and find some tweezers. If you've got tweezers, it might be easy for you. To the other side where you want it to go, like there. And just solder that on there. And if you really want to, you could bring it right round and you could terminate it right here. So you've basically made a bus, because now all of these will match that be grounds. So let's do the termination. Once the end one is on and tensioned, the rest should be child's play. And if you've got some convenient side cutters handy, which again my ones have got walkies, so I'm going to have to use these crude ones, you can just trim it off like so, and then come back and just solder all the other little connections. Bang. And you know now that this wire is giving you 10 amps across the board. Do that again, touch up the beginning and the end. So there, that's your little bus. So I'm going to repeat the exercise now for the rest, and then we'll start soldering the wires straight to this block. First off, the grands. So I'm soldering them inside of the pins, because I'm not sure that our heat shrink is going to work so great on these ones where we made the bus, because I didn't push the bus right down. I've got them sort of floating. Maybe I can do it. Ooh, it sounds crunchy. When I say test, I'm going to test the whole process. Yeah, that's pretty good. I'm going to show you the other way of doing heat shrink, which is the sort of cheap and nasty way with a lighter. So you've got kids in the house, lighters are a little bit of a danger. But look, just to show you the end result there. See? Not too shabby. Not too shabby at all. Remember, this whole block, when you're done, you can either mount it or put some resin over it or somehow treat it. You've still got a lot of exposed pins here one way or another, and you probably ought to deal with those. Right, I'm going to continue with the rest and wire that up. See you back here in a sec. Next, we have to convince the ATX power supply to come on automatically. So look for this green wire. That's the PS on, power supply on wire, and see where that routes through, and it routes through to this pin. And what you're going to be doing is connecting that pin, which is here, to ground. So you can either do a big jumper like I'm doing like this, or just a little wire link, but there we go. You can just, as I said, wire link, you can just tack a wire just straight across to the two. Again, I was going to do the old heat shrinky stuff on here, but it dawned on me that both these connectors, either way, you've got loads of live connectors, so these are actually going to have to be pretty much isolated anyway, or taped up or something, so I'm not going to bother putting the tiny bit of heat shrink on that. So now when you plough this on, the power supply is going to see that and actually just fire itself up. So the last thing we need to do though is sort out this memory issue there, and that's going to involve wiring our booby board. So our booby board just needs only a few wires actually. It just needs the ground and the power, and we're going to use a spare 12 volts power because we have a couple on here anyway, which is very easy to obtain. And we're just going to then hook up one of these pins, and I'll confirm which one it is in my code, but I need to see if it's a pull-up if it holds up the memory clear and then lets it down, or it keeps it down and then pulls it up. So I need to choose appropriately, but I'll have to look at the datasheet for the machine. But we'll worry about that in a moment. I'll just cut up some wire. Just want to show you, I've hooked up our booby board power on reset. So I've soldered here to the first 2 pins, which is the VIN pin and the ground pin. So holding it that way, pins 1 and 2, you can see there, soldered, and they connect to a 12 volt line here, one of these yellow wires, and one of these black wires, a ground respectively. And what they do is then provide the output for that signal. And I'm going to show you which pin we're going to use for our board, because our pin needs it to be held high while we're in reset and then pull it down to ground when we're not. So if I put one of my probes on the ground pin and the other probe on pin 14, because pin 14 is the one we want, you can see we're in a power off state at the moment. The power supply isn't even plugged in, so we've got nothing. And then when I plug it in, you'll see briefly it should stay at 4 volts. Well, sorry, well, near enough 5. I mean, it's going to say 4 point something. And then you'll see it drop down to 0 shortly. So let's have a go. 3, 2, 1. There it is, 4.8, and then 0. So I know it doesn't seem very exciting. It's not very amazing. You could probably do it using other techniques, but that's all its job. That's all it does for this. But let's say, for example, you wanted one of the other outputs on it. I'm going to put it on pin, I think, pin 5. Let's see. Pin 5 is near enough 5 volts, we'll call it. So when we plug it in, you see there's a delay, and then it goes to 5 volts. So that's the job of this board. And other pins, so for example, that was our pin 5. So I've got a description here. So if we go to pin 9, so we've got 5, 9, 10, 11, 12, 13, 14 and 15. So these 4 start off low and go high, and these 4 start off high and go low. But these are operated at the same time. So the first second, after the first second, 5 and 12 flip their operation, 9 and 13 flip, like that. So basically you can decide if you want 1 second, 2 seconds, 3 seconds or 4, you'll attach it to one of those. Or you want 1 second, 2 second, 3 second, 4, but the inverted outputs you attach to those pins. And the pins on the booby board are clearly numbered to match those. So the only thing left to do then is to just add one more wire, and that wire will go, and I should just turn off this power supply because at the end of the day it's still a mains power supply buzzing away, from pin 14, which is here, I'll just cut that, to our reset pin, which is this yellow one here, which is pin 1. Oh, I didn't twist that. Naughty, naughty. Still, should just be just right. And what you can do is, you can see at the moment it's a bit unwieldy, it's a bit of a mess, and I haven't actually put heat shrink on all the wires from this point onwards, so I'm going to have to come back and sort of clean it all up. But you really want to mount it nicely in a box or something. You've got a lot of bits and pieces here. You don't want any of these things to short out. They could be dangerous if they do, and it'll certainly be dangerous to the equipment. You'll blow something up, if not blow yourself up. Just have a check there. Pin 1 is that one right there. So yeah, mount it, glue it, screw it, however you want onto something, and then put that inside a nice box. So that's it now, and that's our booby board in circuit. So you'll see now when I plug it in, you'll get a power light come on there, and you'll get an RC3 light pops in, because RC3, that one, that is actually set up to come on as well after the initial delay. So you'll see it go off and ping, there you go. And if you are a booby board programmer, yes, of course, you can do all sorts of magic with that and program it to do all sorts of fancy things. If you wanted to, you can actually get the booby board to program to power the whole thing up and off, on and off via the serial port. You can do lots of tricks. So I'm just going to bind this up and then send that off to the happy owner, and they'll be able to mount all this up and be very happy with their ATX power supply. And I guess if they want to, they could always exchange their ATX power supply at a later date by removing this connector. But whoa, there you go, it does come off. Look, that's like a handy little adapter for Taito Phoenix arcade game. Job done. Thanks for watching.